Good afternoon, students. Today I'll continue with the topic acceleration. We know generally bodies do not move with uniform velocity. The velocity of a body changes either in magnitude or in direction, or both in magnitude or direction. For example, the motion of a vehicle in busy market is an example of variable velocity. So we can define acceleration as rate of change of velocity with time. Formula for acceleration is change in velocity upon time. Now, if velocity increases, then it is a accelerated motion, and if velocity decreases, then we can say that is retardation or deceleration. Remember students that retardation is negative of acceleration. The formula for acceleration is velocity upon time. So unit for acceleration will be, we know unit of velocity is meter per second and unit for time is second. So unit for acceleration is meter per second square. This is your SI unit, and CGS unit for acceleration is centimeter per second square. Then whether acceleration is a scalar quantity or vector quantity, remember acceleration is your vector quantity. And symbol to denote your acceleration is A bar. Then what is the formula for calculating acceleration? So remember, acceleration is change in velocity upon time. Let us say that if u is the initial velocity of a body and v is the final velocity of a body and t is the time, then what will be the formula for acceleration? Acceleration will be equal to, as I've told you, change in velocity means final velocity minus initial velocity upon t, right? Then we can write this thing as at is equal to v minus u, or v is equal to u plus at. So if we want to calculate the final velocity of a body, if initial velocity, acceleration and time is given, we can use this equation. Again, I am repeating, acceleration is change in velocity upon time. U is your initial velocity, v is the final velocity of a body, and t is the time taken. From the given equation, a is equal to v minus u upon t. If v is greater than u, that is final velocity is greater than your initial velocity, in that case acceleration comes out to be positive. And if final velocity is less than that of your initial velocity, then a is negative. As I've told you that negative of acceleration is your retardation. Next is uniform acceleration. The acceleration is said to be uniform or constant when equal change in velocity takes place in equal time interval. That is, equal change in velocity in equal interval of time. For example, the motion of a body under gravity, or you can say the free fall of a body, is an example of uniformly accelerated motion. Next is your variable acceleration. If change in velocity is not same in the same interval of time, that is unequal change in velocity in equal interval of time, then that motion is called variable acceleration. For example, the motion of a vehicle on a crowded road is example of variable acceleration, because in that case the velocity keeps on changing, it keeps on increasing, it keeps on decreasing, it is not same in equal interval of time. So we can say that is example of variable acceleration. Next topic is acceleration due to gravity. So students, when a body falls freely under gravity, the acceleration produced in the body due to Earth's gravitational attraction is called acceleration due to gravity. It is denoted by a letter G, and the value of acceleration due to gravity is 9.8 meter per second square. Dear students, when a body falls down, in that case your velocity increases, so we can say acceleration is positive, that is it is plus G. When the body moves vertically upward from the surface of earth, you can see, in that case your velocity decreases and with time, and A is negative, that is minus G. So here G denotes your acceleration due to gravity. Dear students, the value of G, that is acceleration due to gravity, varies from place to place. And it does not depend upon the mass of the body. So remember that G does not depend on mass of a body. Now we'll be solving certain numericals. Dear students, I am solving first numerical from page number 36 from the book itself. So the question is, the speed of the car is 72 km per hour. Express it in meter per second. So solution for this is, you can see the questions from book itself. Unsolved numericals I am solving. Page number 36. I am solving question number 1 right now. So it's given speed is 72 km per hour. We need to express this in meter per second. Remember, whenever you have to convert kilometer per hour into meter per second, multiply by 5 upon 18 and meter per second. So 18 ones are 18, 18 fours are 72. So it comes out to be 4 into 5 is 20. So 20 meter per second. So this way you have to solve the numerical. Whenever you have to convert kilometer per hour into meter per second, just simply multiply the number by 5 upon 18. And reverse is the case. If we have to convert meter per second into kilometer per hour, then multiply by 18 upon 5. Dear students, there is another alternate method to solve this numerical. In case you forget that how to convert kilometer per hour into meter per second, then remember I am writing here kilometer per hour. So we know 1 kilometer has how many meters? It has 1000 meters. And 1 hour has how many seconds? 60 into 60 seconds. So it becomes meter per second. When you will solve this, it will come out to be 5 upon 18. So simply you can multiply again which term you have to convert, that term, and again it comes out to be 20 meter per second. So this is the way to convert kilometer per hour into meter per second. Dear students, now I am solving numerical number 9 from page number 36. What is the question? A body starts from rest and acquires a velocity 10 meter per second in 2 seconds. Find acceleration. So first we will write out the given things. It is given a body starts from rest. Remember, when a body starts from rest, or when a body is initially at rest, so we take initial velocity, that is denoted by a letter U, equal to 0. And it acquires a velocity 10 meter per second. This means now final velocity is 10 meter per second. What about time? Time is given out to be 2 seconds. You have to find A. We know the formula for A. A is equal to V minus U upon T. Right? V is 10, U is 0 and time is 2. So it will be equal to 10 upon 2 meter per second square. As we all know that unit of acceleration is meter per second square. So it comes out to be 5 meter per second square. This is your answer. I hope you are able to understand the numerical. Dear students, yesterday I told you that distance is always positive while displacement can be positive, negative or zero. And displacement can be positive, negative or zero. So I'll give you one example. Suppose a body starts from point A and travels a distance of, let it be 2400 kilometer to point B, and again it comes back to point A, right? Then what is distance and displacement in this case? Again I repeat, a body moves from point A to B and covers a distance of 2400 kilometer, and again it comes back from point B to A. So what is the distance? What is distance? Distance is the total length traveled. So distance will be equal to 2400 plus 2400, that is equal to 4800 kilometer. What about displacement? Displacement in this case is equal to 0. I'll tell you how. Remember students, if a body comes back to its initial position, see here in this case, first it goes from A to B and then again it comes back to A, means its initial and final position is same. In that case, displacement comes out to be 0. So remember, if initial and final position of a body does not changes, or a body returns back to its initial position, then in that case the displacement is 0, but distance can never be equal to 0. So distance will be 2400 kilometer plus 2400 kilometer, that is equal to 4800 kilometer. Another example to explain distance and displacement is, suppose a body moves from A to B, then to C, and again come back to position B. What will be distance in this case? Dear students, from A to B it covers a distance of 5 meter. From B to C 6 meter. From C to B again 6 meter. So total distance will be 5 plus 6 plus 6, that is equal to 17 meter. But what about displacement? Now body moves from A to B, from B to C, and again it comes back from C to B. So the shortest length is from A to B. So displacement will be only 5 meter. I hope you have got this example. Another example to explain negative of displacement is, another example to explain distance and displacement is, suppose a body travels from now B to C, again it comes back to B and then to A. Then what will be the total distance? Now from B to C 6 meter, C to B again 6 meter, B to A 5 meter. So total distance will be 6 plus 6 plus 5, that is equal to 17 meter. What about displacement? Dear students, the body has moved from B to C, again C to B, then from B to A. So initial point was B and final point is now your A. So the total displacement is how much? It is 5. So it will be negative 5 meter in a direction from B to C and plus 5 meter in the direction B to A. So this was the example to explain negative displacement and positive displacement. I'll give you one more example of zero displacement. When a body is moving in a circular motion, suppose a body is moving from this point and it is moving in a circular motion and again it reaches back to this point. So in that case also your displacement is equal to 0. Why? Because a body has started initial and final position of a body is same. So in this case your displacement is 0. So this was all about distance and displacement. Dear students, I am solving now question number 6 from page number 36. I'll read out the question for you people. A car travels first 30 km with a uniform speed of 60 km per hour and next 30 km with a speed of 40 km per hour. Calculate total time of journey. So the question is that a car travels first 30 kilometers with a speed of 60 km per hour and the next distance, that is 30 km, with a speed of 40 km per hour. You have to find total time. So how you can find total time? First find time taken from traveling from point A to B and then calculate time taken from traveling from B to C. So let us say this is T1 and this is T2. So T1 will be equal to, we know speed is equal to distance upon time. So time will be equal to distance upon speed. So it will be, what is distance in this case? It is 30, and what is speed? It is 60 km per hour. So it will come out to be, kilometer cancels, it comes out to be 1 upon 2 r. Then what about T2? It is equal to again 30 upon 40, that is equal to 3 upon 4 r. Right? Total time will be equal to T1 plus T2, that is equal to 1 upon 2 plus 3 upon 4 r, that is equal to, they call the LCM, 2 plus 3 r, that is equal to 5 upon 4 r. Can we convert 5 hours into minutes? So it will be into 60 minutes. It comes out to be 75 minutes because 15 5s are 75. So this was the total time of journey. Now students, next part is you have to find average speed of the car. As I've already told you that formula for calculating average speed is total distance upon total time taken. Total time. Here total distance is 30 plus 30. And what about total time? That is kilometer. And total time is 75 minutes. So it will be 60 kilometer. Can we convert minutes into hours? If I have to convert minutes into hours, I have to divide this by 60. So it comes out to be 60 upon 75, again 60. So it comes out to be equal to 48 kilometer per hour. While solving, it comes out to be 48 kilometer per hour. So average speed of the car is 48 kilometer per hour. Next numerical is numerical number 15. Again same page number 36 from book. I am reading the question for you people. A bicycle initially moving with a velocity 5 meter per second means initial velocity denoted by u is given out to be 5 meter per second. Then time is given, accelerates for 5 seconds, time is given out to be 5 seconds, and acceleration is given out to be 2 meter per second square. You have to find final velocity of a body. We know final velocity, it is denoted by a letter v. We know the formula A is equal to v minus u upon t, or from this formula only we derive the equation v is equal to u plus at, and we will put the values directly here. We have to find final velocity, that is v. Initial velocity is given out to be 5. Acceleration is given out to be 2 and time is given out to be 5 again. So it will be 5 plus 10, that is equal to 15 meter per second. So final velocity of a bicycle is 15 meter per second. Dear students, next question is question number 7. A train takes 2 hours to reach station B from A and then 3 hours to return from B to A. The distance between two stations is 200 kilometer. So it takes 2 hours from to reach from A to B, and from B to A it takes how many hours? 3 hours, and the distance between two stations is 200 kilometer. You have to find average speed. As you all know, formula for average speed is total distance upon total time. So from the figure itself, what is the total distance? A to B, and then again it comes back from B to A. So total distance is 200 plus 200 up, and total time is 2 plus 3, that is 400 upon 5. That comes out to be 80 kilometer per hour. So total average speed is 80 kilometer per hour. Next you have to find average velocity. Students, average velocity can be calculated as total displacement upon total time. Now look at the figure. What is the total displacement? Train goes from A to B and again it comes back from B to A. Means initial and final position is same. It reaches back to its initial position. So displacement will be equal to 0. As displacement is 0, your average velocity will also be equal to 0.